Hi everyone, today we are going to talk about how to delete a node in the linked list by index. We already have a list over here. Let me just comment this thing out. And if we run this, so we have 5 elements in this linked list which were previously added, and the goal is to remove elements in this list. And for that we have this method called remove, which doesn't return anything, and it takes one argument, the index that we want to delete from the list. So this is the list that we have. We have the head node, which is the 4, and then we have the 10, 24, 5, 44. They all have the node contains the actual data, and the address to the next node that it is pointing towards. And unlike deleting array list, where let's say we have a same array list which contains similar elements, exact same elements, 4, 10, 24, 5, and 44, and we need to get rid of this number 10 from it, which is index 1. What Java does under the hood is when we call the delete operation or remove, and pass it an index 1, it's going to recreate this array list again and store it in a different memory location without the element 10 in it. But in case of linked lists, it's slightly different. As we know, a node consists of the element, the data, and it contains the reference to the next node. That is the memory location where exactly it is stored in the memory, since these are not stored next to each other in the memory location. So deleting the node doesn't require Java to create a new location in the memory to store all the elements. Instead, it just changes the references of one node to point to a different node. So in case we had to delete the 10 from it, all we have to do is the previous node, which is 4, will point to the next node after 10. So we'll see this in a second. But before that, when we delete a node using its index, there are like few different scenarios that we can run into, few different cases we can run into. One is like deleting the head node. If we give the index as 0 itself, that means we want to delete the head node. See, let's do this. Okay, so this is our 0th node, 0, 1, 2, 3, 4, and let's say we want to delete something at the end, then we'll pass the index 4. We delete some node in the middle of the list. Let's say we want to delete 1, an example that we just discussed, and delete a node that does not exist, let's say a random number 10. Okay, so these are basically the test cases that we will have to test against. So what happens when we want to delete this node 0 with index 0 in it? That means we want to get rid of the head node. What does that mean? That means our new head is going to be 10 instead of 4. So this is the simplest of all operation. All we have to do is move this head to 10, and linked list will automatically get rid of the first node. So this will stop to exist, and now we have the new not the new linked list, but the updated linked list, which doesn't contain the head node or the previous head node at index 0. New head is 10 now. And let's code this out. So how do we do this thing? Okay, so we have a main function over here, and we want to call the remove um, at index 0 from it. What we'll do here is we'll first check to see if the head exists or not. That's very important. If there is no head to delete, what are we going to delete? So we can write a simple check over here which says if the head is null, then we print out saying, hey, the list is empty, nothing to delete. Then we can just return from it. We're not returning anything, but we just have a return statement, so the function doesn't try to execute the next steps which are not necessary. Now let's say the index is 0. That's what we are trying to test. If the index is equal to 0, then we are going to make sure that our head points to the next node, and we do that by saying head should point to, this is the head node, should point to the next node. So head becomes head.next. Okay, remember the node consists of the element itself and the reference to the next node. So that's what we are changing over here. We are changing the reference for this head node. So this is one of the cases, and we can print this out and see how does it look like. So we are expecting the list to not contain the head node 4, but our new head is 10, and the remaining of the list is going to be 10, 24, 5, 10. So let's print this thing out. First I will print the original list before deleting. Let me just type this thing out. Before deletion, before removing, and let's do one after removing. Okay, let me clean this code up. Okay, let's run this and see what's going on. Okay, so we have the original list, and actually I can make this but no, I think let's leave it for now. So we have the original list over here which has 5 elements, and then we have this updated list which has 4 elements. So far so good. We deleted the head node, put a simple. Next is deleting node at the end, and when I say at the end, we are explicitly passing the index to it, and that's the index is 0, 1, 2, 3, 4 at index 4. Let's do index 4. Okay, make sure this is visible enough for you guys. Okay, how do we do this thing? It's similar to what we did before, but we need to traverse until we reach the node 4. And how do we do that traversal? We can use a for loop or a while loop to iterate through this loop. Let's use a while loop for now, and we can implement using next loop and for loop the next time. So here we are, and currently we have removed the first index. Now we want to remove the index 4, which is the last element. So we need to keep a track of the current node, and we also need to track of the index. So first I'm going to save this head node into my current node. So while iterating through, I'm starting with the head node, which is initially at index 0, or or in our case it sets 4. Um, and I need to make sure that I need some sort of counter to increment, so I know where exactly to stop, which is like when the index reaches 4 in this case, since we want to delete the item from item number 4, item at index 4, sorry. And how do I do that? I create a while loop. I need to make sure my counter doesn't go past the last element, the element that I want to remove using the index that I'm providing. And I also need to make sure my current node is not null. This is important in the later section when we try to test out of bound condition. So first, this is just the iteration method where I say the current node becomes current node dot next. I'm just going traversing through the list and I'm incrementing the value as I go. So when the index reaches 4, as it gradually increases, check here, I'm not stopping exactly at 4. I want to stop a node before that. And why is this important? Because remember, like in the case of head node, we wanted the head node to point towards the next node and get rid of the node that we want to delete. Similarly, in this case, we want to delete the last node, which is index 4, which is 44. So we still want to keep a track of the node previous to it, and we want it, in this case, the node at index 3, which is 5, to point towards the next node. So after deleting, this will look something like this. Let me make some space for this. Oops. So I want, remember this I'm stopping an index before the end. So I'm stopping over here, and all I'm going to say is, okay, point this next node to the next of the one that I want to delete. So get rid of this node, get rid of this pointer, and get rid of this pointer as well. So all I'm doing is updating the index over here to be null, which happens to be null in this case, since this is the last node in the list. And what I will do is, once I have traversed through the loop, that means I have my I has reached just an index before the last one, I'm going to make the current node dot next, which is current node dot next. So current node is 5 dot next, to point it to the node past its next node. So current node dot next, and that's it. Let's run this out and see if it's actually working. So we will initially see the list as 4, 10, 24, 5, 44, and afterwards we will be missing. Once we remove the last index, we'll be left with only these 4 elements. So let's run it again. Let's clean this thing up so there is no confusion. Trigger it again. Okay, that looks correct. We have 4, 10, 24, 5 as the remaining nodes, and we deleted the last node. So this is all good. So far we're doing good. Next is we want to delete something that is in the middle of the list. So let's say 1. like our first example that we were trying to test, where we want to remove 10 from the list. How do we do that? It's we almost coded uh, everything already when we wrote the code to remove the last index. So there's nothing different to do over here. All we can do is put the index past the index 1, and we should now have a list which is missing 10 instead of 44. So let's run this again, and here we are, 4, 10, 24. Oh, we are missing the 10 as expected. That's removed. This is all good. The last case is the interesting one. That is something we need to tweak the logic a little bit. Okay, if we are trying to delete something that does not exist, something that is way out of bound, how we will do that? If, let's say, if we pass index which is, let's say, 10, and we do not have any items, or the node is not long enough to be, how do we delete it? It's again very simple. We have written most of the code for it, and let me just copy the original one over here to see. So this is the original node, and we want to delete something. Delete 10. Delete item at index 10. And this 10 doesn't exist. This index doesn't exist anymore. We have most of the code written again over here, but imagine the index, not imagine, let's write it down. So we have 10 over here. What happens is 10 comes over here, it goes through this condition. We have head, we don't want to worry about that. We are not removing a head because the index is not 0, and now we have an index which is out of bound. So this is where the condition that I had initially mentioned will come into picture, where we now have an index of 10. So when the item when the I comes over here and it has incremented to the length of the list, which is 4, it's going to stop over here. That's because our current node doesn't go past 4. So I is 4. That means we have reached the end of the list. So we need to add another check over here. If our current node equals to null, then we just remove that element out of, then we just print out saying, hey, the node that you are trying to delete is out of bound. And we can just do index out of bound error, a message that we are just sending. Let's run this thing. We have the original numbers over here, deleting something that does not exist. Let's rerun it, and oops, here we are. We got index out of bound error. We also got an exception. Okay, and yeah, that's because it's trying to execute the next element, next statement in the list. So we can stop that by just returning over here, and here we go. We have, before removing, we had 5 elements. After an attempt to remove an element that does not exist, we are left with 5 elements as well. So that concludes our deleting different nodes from a linked list. Thanks everyone. See you soon.